So we want to think about octets. How does that work with sharing electrons? Let's start with drawing Lewis structures for some simple homonuclear diatomic molecules. These are molecules with two atoms where both atoms are the same. We are going to use the octet rule, which states that elements like to have 8 valence electrons around them. Remember that when a metal reacts with a nonmetal, the metal is happy to give away electrons, while the nonmetal likes to gain electrons. Thus, they can get to octets of valence electrons simply by transferring electrons, leading to ions and ionic compounds. But when two nonmetals come together, neither one wants to give away electrons, so in order to get octets, they must share electrons, leading to covalent bonds and covalent compounds. We start with dichlorine. Chlorine atoms have 7 valence electrons, and we sometimes see chlorine atoms shown with 7 dots. Since 3 of the 4 valence orbitals on chlorine are filled, we draw 3 pairs of dots and 1 single dot to represent the unpaired electron. If each chlorine will agree to share one of its electrons with the other, then each atom will feel 8 electrons around it. We end up with one shared pair, which we represent with a line between the two atoms. Let's introduce some terminology. The 2 electrons that are shared are called a shared or bonding pair of electrons. The unshared pairs of electrons are usually called lone pairs. The Venn diagram in the picture suggests to us that the atom on the left feels 8 electrons around it, 3 lone pairs and a shared pair. Likewise, the atom on the right feels 8 electrons as well, satisfying the octet rule. Chemists also talk about the bond order of a bond. This is the number of shared pairs between 2 atoms. Because there's one shared pair, we would say that the Cl-Cl bond is a single bond with a bond order of 1. For dioxygen, we have 2 oxygen atoms, each with 6 electrons. An oxygen atom would have 2 unpaired electrons, so we'll show 2 single dots, as well as 2 pairs of electrons on each atom. In order to get to 8 electrons, each oxygen requires its partner to share 2 electrons. This leads to a Lewis structure for the molecule with 2 shared pairs and 4 lone pairs, 2 on each atom. For dinitrogen, each nitrogen atom has 5 valence electrons. In order to get to 8, each atom requires its partner to share 3 electrons. This leads to a Lewis structure with 3 shared pairs and 1 lone pair on each nitrogen atom. Notice that on dioxygen, the 12 total electrons that were shown for the individual atoms are preserved in the molecule, 4 shared electrons and 8 unshared electrons. In dinitrogen, there are a total of 10 electrons, 5 from each individual atom, in the 3 shared pairs and the 2 lone pairs. We can summarize the language we would use in describing these Lewis structures in this table. For dichlorine, we saw a single bond where there was 1 shared pair. This bond has a bond order of 1. Dioxygen has a double bond with 2 shared pairs. The bond has a bond order of 2. Dinitrogen has a triple bond with 3 shared pairs. The bond has a bond order of 3. Bond order seems simple, and it usually is, but we'll see one twist later on. And before we get too comfortable with this method of starting with individual atoms and sharing electrons, that becomes much more difficult with more complicated molecules. So we'll need a better method with some shortcuts, and we'll see that next.